Hi, I'm Mia Quinn, your host of Sustainably Speaking. We talk a lot about innovations in reusing and recycling materials to create a more circular economy. Today, though, we're going to learn about how recycled plastics could be paving the way for more sustainable infrastructure. So joining me to talk about this is an expert, and his name is Bill Buttlar. At the University of Missouri, he's the Glen Barton Chair in Flexible Pavement Technology, where he oversees the Mizzou Asphalt Pavement and Innovation Lab. Bill, thanks for being with us today.
Well, thanks, Mia.
I'm curious, what's the class you taught today?
It's called Asphalt Materials and Mixture Design.
Wow. And is it a graduate course?
Yeah, this one focuses on designing asphalt and aggregate mixtures and sustainability. We talk about fracture tests, like this broken specimen here. But there's other courses in pavement design. There's management courses, pavement management, rehabilitations.
So you're using plastic, recycled plastic, to create more sustainable roads? Tell me about this.
Yeah, these are more durable roads. They're going to last longer. And really what springboarded this was that we've been using brand new polymers in asphalt pavements to extend their life for about the past 30 years. And now with this big push for sustainability and with plastic in the environment, it all came together probably in the past 5 years. Why don't we use recycled plastic instead of new plastic in things like roads where we don't need it to be perfectly clean or a certain color, or we don't even need it to be a certain type of plastic, just in a range of mixed plastic.
So then how's that being taken out of the lab?
In the lab, we put it through tests that try to simulate cold temperatures, warm temperatures, cycling moisture, freezing and thawing, heavy loads, all that. So we really torture the material, put it through its paces, and then if it checks out, the Department of Transportation will want to build demonstration projects or pilot projects because you want to make sure that you can build it in the road the same way you can make a specimen in the laboratory. And then you have to answer questions about, is it a smooth ride? Is it a quiet ride? Is this a comfortable pavement? Is it safe? When you hit the brakes, does the car stop?
Well, in this case, recycled plastics. How are you using them to pave or improve roads?
The asphalt that's on the surface of the road, the very top layer that, it's feeling the tractor trailer traffic, it's feeling those freeze-thaw cycles. It has to be extremely tough. It has to be extremely strong. An asphalt concrete mixture will get us most of the way there, but in certain applications where you have heavier traffic, like your interstates or your state roads, your city beltways, they might need a little extra help. And that's where plastics come into play. They can take that fairly tough asphalt material and take it to the next level. Polymers have been engineered for decades and decades to really lightweight yet tough materials. Think of how much weight you can put in a light grocery bag. So you take advantage of that chemistry inside of the asphalt. So it's kind of working hand in hand with that asphalt binder. If you think about climate change, changing temperatures, changing weather patterns, it's pretty harsh out there on the roadways, and this is a great way to combat those forces.
So are you saying using some of this used plastic can make these roads more durable to mean less potholes?
Yeah, that extra strength that you get from putting plastic in asphalt is going to not only extend the life, but during that service life, you're going to have less cracks, less, rutting, as we call it, and yes, less potholes.
Does that also mean then less road work? Like they don't have to work on it as often?
Yes, that's exactly what that would mean. Work zone safety is really, really critical. So anytime we can stretch out or avoid construction altogether, it does help with safety.
So is plastic a solution to help fix our nation's aging infrastructure?
I would say so. I mean, we're a few years into this research, and it's really checking all the boxes at this point. We're finding that it's making the mix more durable, obviously more sustainable, and we're finding formulations that are reducing the cost. And that's sort of the trifecta. If you can get the economics and the durability and the sustainability all going in the right direction, it's almost like, why aren't we doing more of this? Why wouldn't we do this?
So people like me who aren't in depth like you are like, well, why can't we just do it? How long is this going to take?
I believe that in certain states, at least, like Missouri, We can move pretty fast with the research, the pilot projects, and then creating specifications. So working together, the innovators, the contractors, the owner agencies, state highway authorities, they have roundtable meetings often to discuss innovations such as this. Probably what will add another year or two to the equation is the supply chain. So on one hand, you're like, wait a second, there's plastic, there's no problem with supply. But you can't just, it doesn't just magically go from landfill or the curbside collection into the road. There have to be companies that set up to work either independently or with communities to collect, sort, clean, and then create the right material, the right feedstock for use in construction.
So, where are the used plastics coming from? I guess, where are they coming from now? And where do you see them coming from once it scales to be used beyond a demonstration project?
Yeah, I think there's certain plastic that's not being recycled at a high percentage. And so our early demonstrations are using those sources of plastics.
So, you have no problem with supply right now.
Oh, there's a lot of it. And I think that, if there's an area that is doing this type of recycling, we'll see some recycling centers popping up because there's some local economic benefits to be had if you're doing that in your own community.
So, tell me about your lab. You've got the Asphalt Pavement and Innovation Lab. Tell me about what you're doing.
On any given day, you could see somebody working on a futuristic, sustainable asphalt design using a new plastic source that's come available. You could see a student doing a simulation of video feeds from a road. We look for potholes. We plot the road condition and the comfort and the safety. You could see a student working on building a digital twin of something. And, they might be modeling the roadway or the bridge.
So students there, what do they go on to do? Are they in the construction or planning?
Our students could work for a designer, a civil architectural construction firm that will do the blueprints, if you would, or the 3D digital design of roads and pavements. They could work for a supplier. They could work for an asphalt company or an oil company to blend or to engineer asphalts or modified asphalts and supply those to contractors.
It's really cool. There's your pitch for incoming students. Now I'm curious, how'd you get into this?
My story is this. I worked in structural engineering and materials at Penn State University. And we got this massive research grant that led to the modern asphalt specification that we use now. And Penn State got this grant and they started pulling people out of different fields and we started analyzing roads. I was a good modeler, so I could, model a road, build a digital twin of a road or a lab test. And I love doing sustainability and recycling, so it was a perfect fit for me.
So, yeah, tell us about the lab and look, what does it look like? What do you have there?
Essentially, when you walk in the lab, you'll see all things asphalt. So you'll see shelves that will have clear containers so that when we have visitors, they can see, oh, there's rubber that came from a tire. There's some plastics that looks like a shredded bag. And then you'll see all these specimens. And so you see cylinders and prismatic or, beam-shaped specimens. And some of them have been tortured. And so you'll see a lot of broken asphalt because we need to make it and break it in order to not break it in the field. So we figure out what its limit is. And then when we design our road in the field, we'll make it thick enough so that it doesn't get that crack in it or that pothole. And so you'll see a lot of mock-ups, a lot of models of smaller chunks of pavement and units, kind of a representative volume of a material that will get tortures. And you'll see refrigerators because we have to cool down the material to simulate freezing temperatures. And you'll see different water baths that can be heated up to summertime temperatures or air chambers that can just give it a blast of heat. We also have aging, so UV radiation and aging simulators, but we have multiple labs. And so we have material labs that break down the material and get it into the small size. Then we have the lab that I just described. And then we have more sciencey labs that do test the little parts of material, just test the plastic individually. Or we have environmental studies where we look with electron microscopes at the plastic after it melts into the asphalt to make sure it's taking the right kind of melted shape and to optimize that. We can look at leaching studies. One question is, hey, can we take roofing shingles and put those in asphalt or the road foundation? And the Missouri Department of Natural Resources said, well, you need to prove to us that it won't leach out any chemicals that would be harmful to the aquatic environment. And so we do studies to make sure everything we put out there is not leaching particles or chemicals.
So what's the downside? Are there risks? And I guess leaching is one, and you're studying that to make sure that anything dangerous or anything that shouldn't be coming out of this material isn't coming out of this material.
Yeah, that's right. So there's really two environmental impact studies. One would be leaching of chemicals like zinc. We know that they use zinc in the production of tires. We have to make sure that once we clean and grind up the plastic and then melt it into the asphalt, that we don't have really highly measurable leachate coming out that we'd be concerned about. But the other thing is particles, like microparticles, microplastics. We have to make sure that the asphalt is not producing or generating microplastics in any significant amounts. And so we have studies where we simulate years and years and years of environment and traffic, and we measure any particles that might come out of the asphalt. And luckily, it's very, very low. It's trace amounts. It's stay below EPA standards for all that.
Good, but I'm glad that's all being studied and that's part of this development process.
Yeah, it was one of the first things we looked at.
This is so interesting and I think so cool. I mean, I'm imagining this like in airports, like paving like runways. I mean, talk about taking a beating.
Highways, you have to design for millions of load repetitions. With airports, there's just not as many aircraft operations, but boy, when an aircraft goes across a pavement, it really bends it. A Boeing 747, extended range is like 1.3 million pounds. It's a very heavy bird.
Wow.
And so it's kind of a punishing load. But you can build airports out of either asphalt or concrete. But when you build with asphalt, it has to be a stronger, stiffer design. So we're pretty excited about plastic modified asphalt for airfields.
Bill, I just want to thank you for the work you're doing. It's important, it's smart, and I appreciate you telling us about it and taking the time to talk with us about it. And thanks for being here today.
Appreciate the opportunity to talk to everybody, and I really enjoy the podcast.
And to our listeners, thanks for joining us. Are there any topics that you'd like to bring up on the next show? Let us know. I look forward to sustainably speaking with you soon.